Next, we're going to take a look at graphing our base e as well as the natural log function. Starting with our e to the x, because e is a decimal base, raising it to powers is just punching buttons on your calculator. So I didn't want to waste time in the video doing that. So I have my first t-chart filled out with some values, x values and y values. So to get the inverse function, y equals natural log of x, we will flip our x and our y values. So all of our y values become x values. And all of our x values become y values. So graphing these, if my calibration works well this time, we have -2 and a little bit above 0, -1 and a little bit more than a quarter, 0, 1, 1, not quite 3, and 2, not quite 8. So this, like all exponential functions, has as its asymptote the x-axis. So the graph gets very, very, very close, but doesn't ever actually touch the x-axis, although to our eyes it looks like it is touching. Because again, remember, if we had -100 as our x value, e to the -100th power would be 1 over e to the 100, which for all practical purposes is 0. So graphing the natural log function, again, if you want to think about this y equals x line that all inverse graphs are reflected across, you'll see the symmetry as I graph this one. And the natural log, like all log functions, gets very, very close, but doesn't actually touch the y-axis. But to our eyes, it does look like it gets there. All right, so talking about domain and range again. Domain for all exponential functions, you can use negative, 0, and positive exponents, so we've got all real numbers. But again, as we talked about, even the negative exponents, it flips it, but it does not make it negative or even equal to 0. Y is simply greater than 0. And like all inverses, the domain and the range switch for the log function. So looking at the y-axis as our asymptote for the log function, you can't put a negative value into a log because you don't get a negative value out of an exponential function. However, the range is all real numbers because you can put all real numbers into an exponential, so you get all numbers out of a log, its inverse. We're going to graph a couple more, starting with a transformation of our e to the x function by shifting it up 3. So again, I've already got these values filled out for you, so we're just going to plot them. All right, so this time, because our exponential was shifted up 3, that becomes our new asymptote, this line that the graph comes very, 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 very close to, but doesn't actually cross. So the domain for this is still all real numbers, but the range got shifted up 3. And the last graph we're going to take a look at in this video is negative natural log of x. So remember, multiplying by a negative is a reflection. If you're multiplying the whole function by a negative, that's a vertical reflection. It's outside the asylum, so it flips it across the x-axis when it is a vertical flip. And then if you were taking natural log of negative x, that would be a horizontal reflection, which would flip it across the y. So again, ours is flipped across the x-axis, and you'll see what that looks like as we get some of these points graphed. And if you notice in my t-table that I kind of skipped a few numbers, but even when we put -10 into the natural log function, we're still getting a fairly small number out. So as I'm graphing these, kind of keep that in mind. All right, so this will continue to kind of decrease slowly forever. And of course it gets really, really close to, but doesn't touch our y-axis. It's still our asymptote, the y-axis, because it was a vertical reflection. It actually would still be our asymptote if it were a horizontal reflection as well. It would just be on the other side of the y-axis. All right, so domain for this function, it's still the natural log of x. So we're not affecting the x value, so we're not affecting our domain. So it's greater than 0. And the range is still all real numbers. It just got flipped in different directions.